And the answer here is that surprisingly, at least I think it's very surprising, this algorithm is capable of finding any combination of program and input that halts. And the reason is simple. If a program halts, then the program has a finite length, the input has a finite length, and the number of steps in which the program can run on the input, if it halts, is finite. And at a certain point in time, since this loop here is infinite, max length will be larger than any of those three constraints. And once max length has become large enough, we will find that P terminates on the input after a certain number of steps, and so we will print it. The only reason why the algorithm could not find a certain combination of program and input is that the program does not halt on that input. The first one, amazingly, means that the algorithm is indeed correct. Of course, it is totally infeasible in practice as well, because if you think about it, a program is a text string. Now, even for very, very, very small values of max length, the number of these text strings for the program, and of course also the number of text strings for this input here, becomes exponentially huge. So it's a purely theoretical construct. But it explains why, at least in some theoretical computer science courses, you will hear that the halting problem is referred to as recursively enumerable. So the algorithm is totally impractical, but it is nevertheless correct. And that is the reason why the combination of programs and inputs for which the program halts on the input is called recursively enumerable, at least in some theoretical computer science courses. Now this one is interesting. Can this algorithm be modified to output any programs that don't halt? And the answer here is of course no, because this technique here clearly only works when the program stops. As long as the program goes on, we cannot make any statement about it. We cannot say if the program will still continue running, if it will stop at a certain point in time, and that is the reason why we can't modify this algorithm so that it finds combinations of programs and input that don't halt. This of course also tells you again why the problem is semi-decidable, because we can find those combinations here, but we cannot find those over here.